So then they give us the p-value, 0.26145. They want us to make a decision. So they told us to use an alpha level of 5%, so 0.05. So what's going to be my decision for this p-value? Do I reject or fail to reject? Do not accept. Don't accept. So I'm going to fail to reject. Because the p-value is greater than alpha, I do not reject. So you don't necessarily have to put the numbers, but you do need to do some kind of comparison. Talk about the p-value being the number it is why you make this decision. Okay, so you need some justification on there for the why. So if I'm failing to reject, there is evidence or there is not evidence? It's not. So we do not have evidence that the actual percentage, and if you want to put popcorn kernels that are unpopped, is larger than 2%. Questions on that first one? Anything there? All right, for the second one, we're looking at white blood cell counts. So, are we dealing with means or proportions? Means. T-test or Z-test? T-test. Good. So, when we do a T-test, we need to also say degrees of freedom. Since there were 25 tests done, degrees of freedom is 24, one less. One minus the sample size. We had 25 tests in the sample of those. Now, what do we think the mean number of white blood cell counts should be? 7,500. This is our hypothesized value. So we're saying HO is mu equals 7,500. We want to know, is it significantly different? So what type of inequality shows different? Not equal to. There we go. Then we have a p-value, 0.0263. Our alpha level, they told us to use is 1%, so 0.01. So what's our decision? Do not reject or fail to reject. Good. So that comparison between p-value and alpha is going to be our reasoning. So we do not have evidence that his white blood count is significantly different than normal. What if we change the alpha to 0.05? Would we have the same decision or different? Different. Good. Because then the p-value would be less than alpha, and we would reject. So if you haven't already done so, this goes on page 57 in your notebook. Just go ahead and tape that in there so you don't have a wad of paper from your notebook again. Okay, so once you have that attached, go ahead and turn back to page 53, and we're going to do the math. From like block date? This should be from block date. This should already be in your notebook on page 53. That's what we're getting ready to do. Yeah, that's what we're getting ready to do now. Okay. So, you should recall we have done quite a lot of work with z-scores and finding probabilities. That should be very familiar to you at this point. This formula is based off the z-score formula. Okay, so when you look at it, you should see a lot of similarity. We're just using the values from our sample, the mean and the standard deviation from our sample, to estimate what's happening and get our z-score. So when you look at the formula here for means, you're going to see that we get something that looks very much like our z-score formula. We have a value, which is our sample mean, minus the mean of the population over the standard deviation that we calculate adjusting for sample size. So this is just the same formula we've been doing for a z-score, only now we're finding a t-value. So as we've talked about, for means you use t. For proportions you use the z distribution. So we're going to be calculating a z-score very much like what we've been doing with z-scores. We'll just be looking at the value from the sample compared to the value for the population. For proportions, we'll have z equals, because we're doing a z-test, and the p-hat is just the proportion for our sample. P sub 0 is the hypothesized value, so the one from our null hypothesis. And then we use our standard deviation adjusted for sample size. Okay, so those are the formulas. These are located on the formula sheet. If you go to the page that has the tables on it, you'll see there's our mean and standard, or the standard deviation for sampling distributions for means and proportions. This is just the denominator of those formulas we just did. If you're doing means, this is our denominator. The proportion, this is our denominator. So it's exactly what we just did. If you're looking up here at the top, you'll see our test statistic is the statistic, so the value from the sample, so either p hat or x bar, means or proportions. The parameter, either mu or p, if it's means or proportions, and then the standard deviation is just right here. You pick whether it's means or proportions. It's all right there for you. So this is not a formula you necessarily have to memorize. You just need to know it's right here. Just plug in the values for what you're trying to find. Okay? So don't start worrying that you're going to have to memorize all these formulas. Because they're right there on the formula sheet. So, turn on over to page 55. That page should be blank at this point. And we're going to fill in some examples of doing the math. Page 55 in your notebook. So on page 54, right next to it, you should have where we completed those these things that we did on block day. So you should have those right there next to it. We're going to use a couple of them to show you how the math works, how we came up with the values we have. So I'm going to start with problem 1. So for problem 1, here's what we were told about this one. It says, a magazine is considering the launch of an online edition. The magazine plans to go ahead only if it is convinced that more than 25% of current readers would subscribe. So this 25%, that is our hypothesized value. That is what we use for HO and HA, is that 0.25. Okay? We want more than 25%. So our HA, the inequality, is going to be greater than, because we want more. Okay? We have a simple random sample of 500 current subscribers, so that's our sample size. And then over here, we're told that when we did the 500, we got the sample, we had 137 out of that 500 that would be interested in getting the online edition. And then they give us a p-value here. So, if you're doing this by hand to come up with this p-value, then we would look at our proportion that we had in our hypothesis is 0.25. In our sample, we had 137 out of 500 said they wanted to get this online subscription. Our sample size was 500 of their current customers. So this information should be enough to come up with our value. So for proportions, we want to find a z. So we take the value, which here is our sample statistic, so this 137 over 500, and we subtract the population value, or what we hypothesize is true, 0.25, over the standard deviation. So we do this 0.25 times 1 minus 0.25, or 0.75, over our sample size, and then we take the square root of all that. That's our standard deviation. So then we would just put all this into our handy dandy calculator. When I do that, I get a p-value of I forgot the 5 on there. So I get a p-value of 1.240. Yeah. So ignore the stop part. And that should be what we come up with. So this is our z value. We can look this up on the z table to get our probability. So you can think of it like this. The value of our population is 0.25. If I divide this out, 137 divided by 500, I get 0.274. I'm looking for numbers greater than that. So that's kind of our picture of what we're doing. We have this z-score. This is our proportion. This is our population. So we want to know what's the probability of getting something bigger than that. So how do I get a probability from the z-score? Yeah, so look this up on the table. And since it's shaded to the right, I do 1 minus. So that's my probability. Right there. This value is the probability of getting this amount or more if HO is true. This is my p-value. So on these, yesterday it was just saying, use this p-value. This is how they come up with it. Okay. So what would be your decision for that kind of p-value? Probably would not reject, because that's bigger than 0.05, it's bigger than 0.10. It's a pretty good size value. So probably would not reject. So what if we wanted to do this on the calculator? If we want to do this on the calculator, you're going to use this is stat button, and then go over to test, and then go down and mine is number 5, 1 prop z-test. So that's the one we want to select. Okay, so once you get there, it's going to ask you for some information. This p sub 0, that's the number from your hypothesis. So here is 0.25. Then it's going to ask you for x and n. N is your sample size. X is how many in your sample fit the condition you're looking for. So here is 137. And then it's going to ask you about your inequality. This is what would you have put for your alternative hypothesis. Here, they wanted to know, is it more than 25% subscribed? So we want a greater than. So you go over to that, hit enter, and it will move it over to that. Yes? 137. Yep. Yeah, when you do this, if you put anything in here that's not an integer, it will give you an error. So if you get an error, that might be something to check. So then we want to calculate, and you see it gives you all this stuff. That z, there's our z, p-value right there. So it just gave us both of those by just putting in the numbers. So there's our z, there's our p. We've got the things that we would need to do that. You'll notice it also gets us p hat. So be careful when you're looking at your screen that you don't accidentally use p hat for the p-value. P-value is the one without any notation, it's just p equals. The p hat, that's your sample proportion. So if you're doing this on the calculator, that right there is all you would have to write. Tell me the numbers you put in, and then give me what numbers it gave you back. And that's all you have to do. Questions on that part? Was everyone able to get this on their calculator? Do we have an error or anything going on? Okay. Let's look at problem 2. So here it says, in the past, the average total daily sales for a small food store was known to be $452.80 and followed an approximately normal distribution. The store's management recently implemented some changes in displays of goods, order within aisles, and other changes, and now wants to know whether the average sales volume has changed. So if it just wants to know has changed, what inequality do we use? Not equal to, right? Okay. The manager plans to monitor sales for 12 randomly selected days over the next month. After he gathered that information, he found the mean of his sample to be $501.90. Standard deviation is 65. And here's the p-value he came up with. Okay, so we're going to work through this by hand, and then we'll do on the calculator. So he said the average sales is $452.80. So he's selecting 12 days at random for the next month, and the mean of those 12 days is $501.90, and the standard deviation is $65. So if we're dealing with means, we want to use a T distribution. So we're still doing the sample value minus the population value. So our sample is 501.90 minus our mean for the population, so 452.80, over our adjusted standard deviation, which is going to be 65 divided by square root of 12. So standard deviation divided by square root of sample size. Value of 2.62. Okay, so it's like, okay, so we got this value, what do we do with that? Well, let's go back in the day, so way back in the Stone Ages when I was in college, and we learned how to do this stuff. Way back. The way we did this was slightly different than the way you guys do, because I didn't have one of these. Wish I did, but I didn't. So we would sketch this out. We would say, okay, we have this distribution of T. T is very similar to a z-distribution, but it adjusts for the sample size. So if I'm thinking about a z-distribution, what z-score goes with the middle value? 0. Same with T. Middle is 0. So then we would go, okay, I have a sample size of 12. That means my degrees of freedom is how much? 11. So it's always one less. When you look on your table, at the T table, so when you look at the one that says T distribution, you'll see across the top all of these different tail probabilities. This is our alpha level. Okay? So if I want an alpha of 0.05, I'm looking right here at 0.05, and I want degrees of freedom. You'll see down this side is degrees of freedom. I want degrees of freedom 11. So when I cross those, I get this value of 1.796. So my T, we call this critical value, is 1.796, like I said. So that's my critical value. So what that means is when I go over to 1.796, this area out here is my 5%. Okay? So if I'm at 1.796, the probability of getting a value larger than that is 0.05. If I go beyond that, if I'm at 1.9, the value is smaller than 0.05 because I moved over. I have less area shaded. So we call this, anything over here is when we reject HO because the probability will be smaller than 0.05. Okay? So we call this part the rejection region. Any T value that's greater than this boundary, we reject HO. Okay? So back before we had calculators that could do all of this stuff, we had to look up this value and then compare this test statistic with our critical value to see if we reject or fail to reject. Okay? So here we have a number that's beyond this. It's out here in the rejection region, so we would reject HO. Yes? Yes. Yeah. If they gave you a different alpha, you would use that for the top value. Yes. Yeah. We would have to do exactly what we did here, get this value, and then compare it to the table value. And so that's how we use it, because we wouldn't always get a p-value because we didn't have a way to calculate that. But we could find this critical value and compare these to see if we reject or fail to reject. Sometimes I've seen them do this on the AP exam, talk to you about a critical value and comparing that. So I wanted to go through this to make you understand that's what it's doing. It's giving you anything beyond that, you reject. Anything closer to 0 than that, you don't reject. Okay? Because that probability will be greater than alpha. So, most of the time you'll be able to do this on the calculator though. So, to do this on the calculator, you're going to go back to stat, over to test, and then down to, I believe it's just t-test. Yeah. Down to t-test. And it's going to give you the option, do you have the data that was collected in the sample or do you have the stats from the sample? Here we have the stats. You're going to do some tomorrow where they give you the data and you'll put it in as data and then tell it where the data is in L1 or whatever. So we're going to put this in. Our mu sub 0 is our hypothesized value. It's our value that we use up here as mu. So the $452.80. Our X bar is going to be $501.90. SX is just our standard deviation, $65, and N was 12. and we said we just want to look for, has it changed? So we're looking at a not equal to 0. Once we get all of that put in there, then we just calculate, and there is my t, 2.62, and my p-value, 0.0240. So again, you can see if I'm using alpha of 0.05, I would reject because p-value is smaller. Just like I did up here when I talked about a rejection region, my t-value was past the critical value, so I would reject. So either way, you're making the same decision with the information you're given. Okay. We good? So, right. To get the p-value, we would have to do it on the calculator. Okay. For your exit ticket, I want you to see if you can do this one on your calculator. Just put it in your calculator. Give me what it tells you as your output. As you're working, let me give you some information. Tomorrow, like I say, I will be gone, so you guys will have just a practice over this. Did I already tell you guys this? I've gone through this with every class. I feel like it must. So today is my 1-year kidneyversary for donation. So this is my 1-year anniversary. So tomorrow we go for our 1-year checkup. So we have to go back to Oklahoma City and do our 1-year checkup. So I'll be gone for that. But all you're doing tomorrow is practice problems over this. So the 2 pages that you will get tomorrow in your folder, we already put those in your table of contents so you know where they go. So just make sure those get attached, and you'll just complete those tomorrow in class, and you should be able to be fine, hopefully. Yes, this is your exit ticket.